Okay, is everyone comfortable? At the back there? See you chatting between yourself. Hey. Anyway, yeah. So, welcome. My name's Tim Jones. I am one of the few guys who actually run our Omni SaaS. And so I'm gonna basically explain how we do that, and I'm gonna do it in the form of sort of a historical contest, how it started out, how it migrated, and how it became better, and how it is today. So it started way back in, what was it, June 2022, and this is my actual Git commit message when I was doing this. As you can see there, it's a very, very rough proof of concept cluster that I created. It was a single bare metal node that I hand rolled myself with Talus. At Sidero Labs, we dog food all of our own products. We run Talus on all of our clusters, and we manage those clusters now with Omni. But this was all pre-Omni. This was before even Omni had a name. This was very, very high concept stuff. So it was just a single bare metal node in a data center that we were renting out. And DNS was manually set up in like Route 53, so not even using like external DNS or anything like that at that point. Applications were managed on this cluster using Helm file. If you're aware of that, it was adequate. It works. And whenever we had someone who wanted to come and test our proof of concept, we would manually create deployments of Omni in that cluster with Helm file. So I wrote a chart, and it was literally just a deployment, ingress, a few other bits and bobs, and we would just say, hey, give a new account, a new instance to these people, and everything was super manually set up. We also have if any of you have used Omni, in fact, have we got any hands who've used Omni? Awesome! Wow, that's pretty cool. So you have like a WireGuard link that connects all of your machines together to Omni. At the very principle, that had to be like handpicked from the ports we had available on the server and assigned to machines. There was everything else was completely hand rolled. And very simply, it was like an Ingress Nginx for the ingress controller, and we used Dex for cluster auth. Really, really simple setup, nothing complicated at all. It started going off. It was moving very, very quickly. We moved all of our infrastructure. We started to actually manage it. We used Pulumi. We used Pulumi to manage both the infrastructure, which again, still just a single node machine, but also the applications all as well. So we sort of, I think we were moved off Helm file at that point. Some parts were still, but we migrated to Pulumi for pretty much everything else. One of the problems we ran into with that was it kind of limited us to just using Helm charts. So back then it wasn't such a big problem. Nowadays, since Customize has like been integrated into Kube Control, it's like more the official way of managing stuff. It started to limit us. For instance, Cert Manager does Customize by default, and you have to go to the community if you want a help chart, things like that. It started becoming a little bit painful. But it gave us support for adding load balancer configuration for Omni, so we could actually, add more nodes if we needed to, things like that. Accounts were still very much manually rolled by literally Andrew, the CTO, would, if he got someone saying, hey, I want to try out your new thing, he would literally write down, give them a password, encrypt that, and put it into the hard-coded config. Very, very startup stuff. I'm sure you're all familiar. But at this point, we actually had real companies using it, not in their production environment, but third parties really, really interested in it, and some of those are actually still with us today. So it wasn't too bad. So at this point, we actually start to get some workload. We start to migrate the cluster from a single node cluster into something that's more production grade. We created a HA control plane. And we did this with what we like to call the hybrid cluster model. So because we do most of our actual work with bare metal servers, as like Steve mentioned this morning, if you wanted to do that with a control plane, you're talking about dedicating 1624 CPU and 64 gig of RAM to a control plane. It's absolutely astronomical and then completely ridiculous. So we actually created the hybrid model, which allows us to run the control plane as VMs in a cloud provider. In this case, it was GCP. And all of the workers were on those bare metal nodes. So I think we added another one. So the control plane was being GCT, a couple of workers in bare metal nodes. And it was limited to like everything being AMD 64 still. The Pulumi was still managing all of this, and we were writing more and more Pulumi to wrangle all of that stuff together. Importing stuff was way harder. Like if you're going to write with Terraform or Pulumi, just start with that. Don't try and import running stuff. It's just a nightmare. And then, like, at the end of the first month, we finally added monitoring. So we'd done all of that blind. Our HA control planes, actual running Omni instances, everything like that, absolutely, completely, utterly blind, which was terrifying. Luckily, it was a proof of concept, so not the worst thing in the world, but still not fun to troubleshoot that when you have actual... not paying clients, but still clients that you hope will pay you one day, and you have to make sure things are working for them. So we just brought in super quickly Prometheus stack. So that's Kubernetes, Prometheus with the node exporters, all of that prepackaged for you in a really simple Helm chart, throws in Grafana, and gives you a lot of very generic alarms and alerts and dashboards out of the box. Be careful. It definitely doesn't target everything you'd want a cluster to be aware of, and a lot of the values were not optimal to our use case. So if you do something like use Kubernetes stack, know that you will absolutely 100% have to tweak them. For instance, like we would only get notified when the CPU was high on a node when it hits like 95% CPU usage, which is just insane. So, as everyone knows here, nothing's more permanent than a temporary solution. So this proof of concept, absolutely very basic cluster, now had enough working on it that we needed real persistence. Like that monitoring would only persist as long as the node stayed there. You know, as soon as the pod restarted, goodbye. So we brought in Rook Ceph. Ceph is very heavy, but it's also very bulletproof. Rook, on top of that, if you're aware, is basically orchestration for it. It's good in the sense that it's basically trying to mash old Ceph, which expects, static configs, static servers, lots and lots of parallelism into an all-size-fits-all cluster. And yeah, the defaults aren't good, but they'll get you there. It gives you, block storage, and it gives you object storage and shared storage all in the one sort of default config. So it does its work, but we were still working with only 2 worker nodes at this point. So we basically had to reduce the replication factor. We had to run some of the Rook components, some of the Ceph components on the control plane nodes as well, since we just didn't have enough space for everything. So that was like critical components. We would like the the managers, they would run on the control planes, and only the sort of data serving aspects of Ceph would run on the workers themselves. But that meant we had to then go back and reconfigure our monitoring to actually make it persistent. We added more specific to us alerts. We did a lot of rewriting of the alerts that came with Prometheus stack. And we added Loki for our log fetching, because up until this point, kube control logs pod. That was our ability to look at logs, and that was it. And that was supplied by the Ceph object store within the cluster. So that's another bonus for being able to run that all together and all quite simply and quite holistically. And again, this is still just me and Spencer managing all of this. Me being in the EU, him being in the US. So. Yeah, by the end, not even 2 months later, we finally have a real name. Omni gets rechristened as Omni. Fantastic. So, of course, what happens when you finally get a name for a service you've been running for a while? You tear everything down and rebuild it with a proper name. So I finally managed to get rid of my proof of concept cluster, tidied up a lot of stuff, made things more workable, made things more flexible. And yeah, it was just a chance to clean up the whole cluster, start from scratch, find out all the bits that you'd accidentally added by hand and not put into GitOps. We're big practitioners of GitOps in Sidero Labs. So yeah, cutting a new cluster meant that all of the things we were missing, we suddenly didn't have, and it really helps out. We also at this point moved over to MetalLB. to deal with the IPs, because before Omni was basically, it wasn't using host network, but it was having a single assigned IP, and we were just like manually showing that. And the bare metal provider had added support for BGP routing, so we use MetalLB to announce an IP address from them to both nodes, and that's how we do load balancing. It's not true load balancing, it's just all nodes can respond to requests from that IP address. And that worked pretty much flawlessly. At this point, we were getting a little bit happy because Omni was starting to get successful. We had a lot of people really interested in using it, but we were still manually rolling out those copies of Helm charts. I had at one point taken all of the resources in the Helm chart and put it in a big for loop, so we could just list over the different instances that people want, but it was still doing the same way. So we created Omni controller, sorry. So based on Kube Builder, as most controllers nowadays are, and it was just one single CRD which described the business aspects of an Omni instance, so who it was owned by. It would give it a UUID so we can track it everywhere, an SKU as well back then it definitely didn't have an SKU, but it had, to unify everything, to build it up, and we could get rid of the old Helm chart. And instead of doing adding values to a Helm chart, we were now just adding blocks of YAML resources directly into the cluster, one account for each Omni instance. So slightly better, but still not all the way there. All of this up until this point was all in a single cluster. There was no separated environment. So when we wanted to test something, we would go into the cluster and break things. And like I said, as we started getting more and more customers, that's not ideal. So at this point in, September, so still only like a few months from initial creation, we're now adding a non-production environment, and that helped for a long, long time. But it was a shared environment, so it's still on the same cluster, but we could separate releases of the Omni controller, Omni itself into different environments and separate things out that way. Definitely start off the other way around. Much better for your health. And at this point, Omni, before this point, Omni was using BoltDB, or an integrated etcd server, so it would just have a file store within the instance and save everything itself. And we basically, at this point, went, okay, we now need a full-fat etcd. So we rolled one out onto the clusters. This required us scaling up the workers by this point to 3. Excuse me. So we could run etcd as a full cluster. So we have obviously the etcd for the Kubernetes cluster itself, and then a whole other etcd cluster that we managed running in the cluster just for Omni. And initially we used the Bitnami chart for this. That caused some issues down the road. We will get into that. But we were at this point we were really, really sad to find that the etcd operator had been sunset, and I don't know why. It's an awesome piece of tooling, but it's obviously far, far behind on what etcd versions and configuration needs now, so unfortunately we couldn't use that. But yeah, if anyone knows anyone who had anything to do with the maintenance of etcd operator, get them to restart that project. It's phenomenal. If we had the engineering time, we would totally do it ourselves. So we used a Bitnami Helm chart and were okay enough. Obviously reconfigured all of the Omnis to use that. At this point, we were getting really frustrated with Pulumi. State drift was not an uncommon issue. My guess it's more to do with our naivety in using Pulumi rather than Pulumi itself. We were using it because we heard it was the next big thing. It was doing more for us than Terraform. It allowed us to write in Go, which is our language of choice within Sidero Labs. So we were trying it. We were, really trying to make it work, and we just couldn't. We spent more time trying to recover state, trying to rewrite state than we were using it. So we start to break things out, and the first thing to go were the applications, and we just used Argo CD and an application set to deploy those directly from our repos. Made things a lot easier. And I don't want to disparage Pulumi. Absolutely operate error on that, I'm sure, but yeah, we just couldn't get it working to our requirements. So at this point, We add Vault, HashiCorp's Vault, because we want to start like encrypting all of the Omni instances, and they are all encrypted with their own individual keys. So we have a break glass key that allows us to do disaster recovery, but otherwise all of the data stored by Omni is stored in the etcd already ran through encryption, so it doesn't ever touch this without being encrypted. The reason we did it with HashiCorp Vault is because obviously that allows us to basically push everything through the API and not have to have like a shared key for all Omni instances in etcd. It basically, Omni itself gets the encryption key. If you've ever tried it on-prem, rolling it yourself, it's just literally passing it a private key to encrypt everything in within Omni itself before it goes to whichever backend it's using. And yeah, we all separated those all out, and the keys were stored in Vault. We configured Vault itself in a HA mode, but using the Raft storage integrated rather than the S3 or console or anything like that. And honestly, that has been rock solid the entire time. I have no complaints about administrating that. The worst part is just setting it up. The RAF instructions were not particularly fun, but once you figure it out, document it and you're done. It's like a one-time thing. Yeah, so November hits. We have our first big production outage. Things break. And we discover it's basically etcd got full. When you deploy it by default, etcd actually, whenever you deploy etcd, it has a hard limit on the storage space it uses. It is not infinite. It does not just use the storage available on the block device you assign to it. That has a hard-coded limit as well. By default, it is 2 gig. By configuration, you can increase that to 8 gig. You cannot go over 8 gig with etcd. Warning. So we had hit the default 2 gig. So once we discovered this, it was very easy to just change that configuration variable, roll all the pods, and start using more. But it did lead us to do some optimization, like enabling auto compaction and creating sort of a cron job to defrag when disk use and memory use were greater than about 40% or something like that. So yeah, that was a fun time, and the first of, well, we'll see. So this is February. We finally stop creating Omni accounts by hand. This was probably one of the best moments for me as an operator, and also the worst because it suddenly we allowed anyone in the world to come and create an Omni instance. The same process is still in place now. We have a sign-up page. You can enter in the name you want, the sort of subscription you want to pay for it, and hit go, and we deploy you an Omni instance. It made it phenomenal because it cut down a lot of our churn and toil maintenance, but it also exploded our use of Omni, for good and for bad. We learned a lot in that month in how to manage all of this. We also had to add a few other services around that. So the sign-up page, I should say, that does very funky things like checking if the name of the Omni instance you want is available. So this is something I actually fought against this for a long while. I thought we should use the sort of like the UUIDs we generate as your domain name, and only afterwards, once you've signed up for everything, if you want to give it an alias, and we could add a CNAME record for that alias, but your canonical address would be a crappy old UUID. But other people in the company, naming no names, thought that that's bad UX, and the name you select should be the canonical address. Naming no names, and that's how it's been. It's not the end of the world. It's like an extra little check we have to do, but it is unfortunate that couples us slightly. Omni itself isn't coupled that way. It's an operational thing. Within Omni, UUIDs are used, and that's the canonical name. It's just that if you want to change the name of your Omni instance, you can. But right now, it's a step that the operators have to do, because we have to go in and change a field, and that will go off and re-register your DNS entry and all fun stuff like that. But otherwise, it was good. We also added like a mailing service, so you would get like a welcome mail when you signed up, things like that. And we had to hook into, because at this point we We were charging before this. We were charging everybody by manual. Like Steve was doing invoicing one-on-one to the people using it, and with this, we finally actually hooked into a third-party billing service, which allowed us to just automatically create subscriptions after the trial, start charging, or complain that there's no card details for payment and stuff like that. And it basically, that allowed us to grow an awful lot, the Omni service itself, and it allowed a lot of miscreants to use it as well. Hey ho. And that was all handled now, automated, so that account custom resource that we have in the controller, that was being pushed by the third-party billing service, or well, a webhook was being pushed, and we would create an account for that. And the last stage was just to migrate all of the accounts we had created manually up until that point into the billing. So now that billing service is our source of truth for all the Omni accounts, for good or for bad. So, next big failure, and this is 100% on me, complete operator error, completely stupid reason. I make a typo in a PR. So I open up a PR. Instead of writing that the Omni IP address should be this to register the load balancer with BGP and all of that, I write Omni or something like that. I just get 2 letters switched around, which means the controller doesn't have an IP address to put into the load balancer services. So what does that do? It empties the IP address that's already assigned to all of the load balancers, and then the node controller that the bare metal provider hooks into Kubernetes takes that to mean, well, I now need to order this load balancer service and IP. And we had, I want to say, like 150, 170 odd accounts at this point. The cloud infrastructure provider did not have 170 IPs sitting in a list waiting for us. And not only that, I think their BGP routing for their services was limited to only announcing routes for like 30 IPs anyway. So pretty much instantly we hit that limit, and we break their BGP pairing sort of infrastructure, and obviously we break Omni for all of our customers. This was a painful one, mainly because within maybe half an hour tops, we had identified, fixed, and rolled out the fix, but we had to wait on the bare metal provider to clear out their BGP sessions, and they took 4-5 hours to do that. And that was horrific for us because obviously at this point we've got the outage reports, we've already started off the post-mortem, but the mortem. And like I said, we already had the fix. Our instances were now announcing the correct IP address for all the Omni instances. And it was basically their BGP routers were just not accepting that anymore because we had overloaded them with too many routes. And we had to wait for them to basically restart their routers for that. And that was me, 100% me. Do not blame anyone else for that. And then, towards the end of the year, we finally get rid of the last bit of Pulumi, managing the infrastructure, and we moved it to Terraform. We just basically have a lot more experience with Terraform, a lot more time into it. We can manage the state way, way better. It's just more comfortable for us. No personal issues with it. We just couldn't grok Pulumi properly. We have people using it to do phenomenal things, but I just don't get it. So this one wasn't me, but we did have one other really, really big outage towards the end of the year, and this one was terrible, but it was also awesome, and the absolute epitome of why dog fooding is essential. If you can use your own products, absolutely do it, because we upgraded Talus from 1.4 to 1.5, and there was a very, very big change there in which we took the kernel from statically compiled drivers to module-loaded drivers. And that meant our disk IDs changed Talus doesn't really have a problem with that. When Talus boots and wants to find its state and all of the data on Talus, we use partition labels. So it doesn't matter which disk, where it's been enumerated to. It doesn't matter because we look for the labels. I honestly don't know what happens if you manually label a partition in a Talus system with one of our labels. Don't try it, or try it in a lab. But that's how Talus did it. So Talus was booting absolutely fine, but both Rook and a user disk that we used to back the etcd data changed order. So they went from SDD to SDB and stuff like that. And that meant that etcd, that Talus would find a different disk, format it, and mount it with XFS for etcd. etcd, because of the Bitnami chart, started up, saw that it had no data on disk, and assumed that it was making a new cluster. So we also got a split brain on etcd right there. Omni was working fine. The people who were on the etcds that were still part of a quorum, no problem, everything happy. The people who had Omni that had restarted in that time and were talking to the one etcd by itself, they had problems. And basically, at the time this happened, we had no resolution other to continually reboot the node until we just happened to enumerate the disks in the order that they used to be enumerated in. And that was the fix. And it took half an hour for one of the boats, literally just waiting for it to come up, rebooting. And when it did, it worked fine. Obviously, as soon as we had cleared the worst of it, biggest thing is allow user disk mounting of in the Talus configuration to use the udev IDs of disks /dev/disk/by-id. Always use that on real physical hardware. I cannot emphasize that enough. We have absolutely shot ourselves in the foot with that, and now we always use it, and it's like one of the best practices I can personally give. We also added another feature, because normally this wouldn't happen if under normal block device circumstances, because if Talus discovers a block device that is not to the format and to the partition layout and everything like that it expects via the machine user disk config, it won't format it, it won't touch it. If there's even a partition table on that disk, even if the partition table matches, if it doesn't match exactly what Talus expects, it assumes it's a disk in use and therefore doesn't touch it and simply gives you an error. Ceph doesn't use partition tables. It just owns the entire block device, which is why Talus didn't detect it, reformatted one of the Ceph disks and assumed that was the user disk for etcd. We have now added into Talus detection of a Ceph-owned block device using, they have a magic number that they put in certain places along the block device. So we avoid that now. We made two big changes in Talus, and now we avoid that, hopefully for the foreseeable future. But again, absolutely critical dogfood in your device. Had we not done that ourselves, I can guarantee you it wouldn't be fixed. In fact, the being allowed to mount user disks by ID, I believe we actually had that as an issue in our backlog for some time, but it had come in from a home lab or it had come in from the community, something like that. So we knew that we couldn't do it, but we hadn't shot ourselves in the foot yet. And it also sort of very much accelerated our sort of take of using the community to get ahead of big issues. Like what we find out is a lot of our community do this for their day jobs. They might not be able to use Talus in their corporations, in their enterprises, but they almost certainly use Kubernetes. And when they want to replicate it at home, where they're doing hobbies or they're just trying to sort something out, it's really common for them to look at the same problem, or how can I fix this and then take that to work. And we have now basically, once we get a little bit of traction on an issue from the community, that pushes up the backlog quite severely. Not quite as severely as everything else, but once we have a few more people talking about a single issue, then we know that when that issue finally filters its way down into the companies, into the enterprises, they're going to have a much bigger issue with it than the home labbers are. So for everyone who uses it in their home lab, we thank you. Absolutely great issues. Absolutely log things and raise them. Be patient. We're not a big company, but we do want to fix these things. And we also, obviously, at the end of that, we moved off the Bitnami chart because it was doing too much automation. Had a script that, like I said, if it didn't have data on disk, it assumed it was a new cluster. That's a terrible decision to make. And we basically just took the Helm chart out, but left the resources in. So now, like the etcd is just a manually managed set of stateful sets. Well, one stateful set. But not managed by anything other than our manual intervention. Adds on a little bit of operation overhead, but worth it for not getting a split brain, in my opinion. Okay, and now we're finally getting to a point where this little cluster is actually doing some pretty serious work. And we start, not making some money, but we're starting to be able to pay for the servers. And we start bringing in dedicated servers. We bring in 3 dedicated servers, bare metal servers for the etcd load, another bunch for the storage node, and another couple for monitoring. So now we have like 4 storage nodes dedicated just to Rook-Ceph, maybe another 4 that will work as for all of the Omni instances, 3 for etcd, and 2 for monitoring. There should be a bit more. Well, goodness. Okay, so, and that's pretty much as it stands now. So the cluster itself, the infrastructure, is actually deceptively simple. It is not, it's not complex at all, but the very fact that we're using Talus to do it simplifies everything so much more. Like I said, we're still running those control planes in GCP. They're still up there in the cloud. We're still running the nodes with the bare metal provider, just way more of them. Just this week, I think as well, Spencer in the US, while I'm here, he's scaling the storage nodes to have more storage in them, but being able to like replace one at a time, because we had some nodes with only, a terabyte and a half of disks over 3 disks. And he's just putting some big old 4 terabyte disks into a different node and moving them over one by one, and Ceph handles all of that for us. It's phenomenal. On the software side, as far as open source, we use a lot of open source tooling, but Omni itself requires a lot of, not proprietary stuff, but stuff that we've built that only really works for our infrastructure. So we're using Rook. We're using Victoria metrics now. So in this step, when we added dedicated nodes, I forgot to mention we swapped out Prometheus for Victoria metrics. If you're not aware of Victoria metrics, it's based. I don't even know if it's forked from the same code base. I kind of assume it is, but they've separated out rather than it being a monolithic stack like Prometheus. They have, just like Grafana does. They have an agent that's doing the scraping. They have a storage layer, a query layer, an ingester layer. And they separate all of them so you can like scale them out at different requirements and stuff like that. And when we moved to dedicated monitoring nodes, we moved also to Victoria metrics to allow us to separate that out without having to go through the complication of running like Prometheus and Thanos and using object storage to get that long-term data and all of that things. Monitoring I think is a very, very hard problem to solve. I don't think we've solved it yet. But hey, Steve, he founded a monitoring company. Maybe we should get him. They just don't specialize in Kubernetes. But if anyone doesn't know it, I would suggest checking it out. It's without wanting to hurt any feelings. It's like how Prometheus should have been designed for Kubernetes. I'll leave it at that. etcd obviously is the storage backend for Omni itself. We have Dex doing authentication. Now, in all of our other clusters, they're all managed by Omni now. So all of the authentication of the cluster itself is handled for us by Omni. So our discovery service cluster, our staging cluster, our CI pipeline cluster, all of those clusters are managed by Omni within the company. This cluster, because it existed before Omni, is the last cluster not being managed by Omni in our company, and it's probably one of the biggest pushes we have to try and get Talus clusters adoptable by Omni, because we really, really, really want to move this cluster to be managed by Omni as well. But yeah, as far as other authentication stuff goes, Cert Manager, external DNS, and Ingress Nginx, really, really simple stuff. The biggest differences, like our Omni controller, when it lays down ingresses, it's laying down ingresses with a butt ton of annotations, because Omni, with the config patches that you have to send through gRPC, we can't control the size of a customer's config patch. Like, we have a lot of customers who, in their inline manifests configuration for Talus, install something like Argo CD. And I don't know if you've ever looked at the resources that Argo CD needs, even a bare install. It's something like 12, 15,000 lines of YAML, because they define God knows how many CRDs. I mean, the actual deployment of Argo CD itself is what, a couple of stateful sets, 2 deployments, and it's done. It's not nothing, but the declaration of the CRDs is just crazy. And so that has to, we're constantly tweaking those values to get like a responsiveness without loading down the Omni controllers. But one of the benefits of all of our Omni instances being completely independent from one another is, if you have a customer working back at one point, obviously we've got like limits memory and CPU on the pod that's running Omni. So that's you're not going to have so much of a problem with your bad neighbors, with your noisy neighbors and things like that. And all of that is controlled by Argo CD. I mean, everything we're doing up until at this point is really maintenance. Like all of these, there's a lot of toil and churn of getting things up to dated. We use a tool that I cannot remember. It's not like Dependabot from GitHub, but it's something very, very similar. I can't remember. Could be. I can't remember the name, but maybe, yeah. That tells us that there's new stuff ready, but obviously this being production operational stuff, we have to go check the release notes, make sure there's no breaking changes, make sure there's no weird configuration changes that we have to apply. But mainly the majority of the work now is maintenance, keeping everything running. In the future, we are absolutely poised and ready, or at least I am, to duplicate this in the EU. I point here, we are grumpy Brexit, grumpy. But we absolutely want to be able to serve Omni instances in the EU to our EU partners, EU customers that don't like the idea of connecting to a load balancer over in the States to connect to their Kubernetes clusters. It's absolutely on the drawing board. When I get to do it, I don't know. Again, have to talk to Steve about that. When the investment comes through, I guess, this week. But yeah, we're absolutely going to do that. And as Steve mentioned as well this morning, we want to do things like manage control planes. So we take even that load off you, and we can manage those ourselves in our infrastructure, and you only have to worry about the workers. I'm kind of really excited by that. I think it's a really good problem to solve. Whether it's a useful and commercial product is yet to be seen. But yeah, if anyone likes the idea of it, raise some noise about it. It'll help the sort of the planning side of things go a lot better than move it up the list. And I think that's pretty much it. So now random questions. If anyone has any, we got one over there already. Thank you.
Yeah, thanks for this entertainment talk. One question about the etcd deployment. So I had the same struggles with the etcd operator and the Helm chart. Do you know any option not managing it by hand now, or is there something on the horizon maybe someone else knows? To
answer that question, no. I don't know of anything other than doing it by hand at the moment. To sort of go into a little bit more depth, we even entertained the idea of running a Talus cluster with no Kubernetes resources in it, and then using that etcd as our backing for Omni, because we know that Talus can do all of that management because it does it right now. If we were more engineers, if we had more time, if any of the community would like to take it upon themselves, we should be able to extract that intelligence out, make it into a library like all our other open source software. And I mean, Andre did actually raise a point, like when we were discussing this, he was like, if we want to pivot the business, we can absolutely take the intelligence we have, make etcd operator for that. But we only had like 3 software engineers at the time. That if we did that, we would not write Omni. And Omni is what pays the company to be existent. So, yeah, no at the moment, but it should be possible if we have the time or if anyone wants to take it under their wing. It's all open source. It's all there available. We would love that. It would make our lives easier as well, but we have other fish to fry. All of that said, once you do have like 3 independent, I think even we, after a while, we took away the stateful set and actually made them 3 single replica deployments. Like we went hardcore, don't do anything unless I tell you to do it sort of thing. And since then, the only issues we've had as when clients decided to scale their cluster up from 3 to like 1,500 nodes. And they do that by polling their Omni API. Omni API works the same as the Kubernetes API. We have watches. We have a client that allows you to create a watch on a resource. Don't poll the Omni API, and we're golden. We will tell you when resources are available. But they were just polling it, and because in that case the traffic basically passes straight through Omni into etcd. They didn't break anything, but they caused a noticeable slowdown of the entire etcd cluster, and therefore that affected everyone. We are working towards creating cells so we can have customers independently in a cell with their own dedicated etcd, and then maybe like all of hobby tiers can just be in one cell, and then enterprises get their own unique cell. So we are working towards separating out the etcds as well, so even then noisy neighbors. But it's happened once in the 1.5-2 years of Omni being in existence, so it's not a massive concern. etcd does pretty well with that, but yeah, once it's running, it's solid. Just don't allow any intelligence outside of your own hands with etcd. It's crazy.
Just a comment on that. So we have an internal fork with minimal changes to the operator, and we've been using that for the last couple of years. So it's the
Publish
operator.
it.
Yeah, we definitely should. Yeah.
Awesome. No, if you can publish it, I'm very, very lucky. I've worked in a lot of companies before Sidero Labs that very much used open source software and wouldn't allow me to contribute back. And that was always a sticking point for me. So being able to work in Sidero Labs, and again, we've even, it was hard for us when Omni was proprietary, like before we released it under the Bustle license, because it was creating some very real political conflict within the company of, we should be an open source company, but we need to make money. And that's how we landed on Bustle. At least we're not like MPL and then later relicensing under Bustle. We're not going to do any rug pulling. But the fact that we can open source it and we can have contributions, it means an awful lot to us as a company. And we definitely constantly want to take that forward. And we know our roots are in open source. We couldn't exist without Linux being open source. All of this tooling, Kubernetes being open source, it makes us possible. So.
Thanks for the presentation. You mentioned Vault and Terraform.
Mm-hmm.
Any changes there regarding the recent HashiCorp business use license changes?
For us, no. We, as far as I'm aware, none of our stuff competes with any of their stuff. Like our services don't. So we don't have any issues there. But again, when I talk about us using Terraform, because we now have Omni, our Terraform is crazy simple. It is, depending on the provider, it's basically bring up however many machines that we want, and then Omni manages the rest. So if we're in AWS, it's like create a VPC, create a security group, create however many instances, and that's all Terraform does. There's no configuration, there's no complexity to it. It's super simple. So I suspect that Tofu would work for us as well. But until someone tells us that we can't because of those licensing restrictions, it's the path of least resistance for me. Same with Vault. Vault we don't really have. Has there been an open source fork of Vault yet? Yeah. Okay. Well, I don't even know that. You see. But yeah, I suspect until there's a serious need, like a legal need, we'll just use those because it's simply the path of least resistance. It requires the least change. Anyone else? Well, if there's no more questions, you can have 10 minutes of your lives back? Thank you very much.